Welcome to the peaceful space of sleep-friendly science, where we gently wonder about the very blueprint of our reality and the origin of its fundamental rules. As your body softens and your mind begins to drift, consider this quiet question with me. The laws of physics, gravity, thermodynamics, electromagnetism feel like absolute truths. But did we simply uncover them, like archaeologists finding a hidden city? Or are they a beautiful, complex language we invented to make sense of the cosmos? Now, settle in, take a deep breath, and let the soft sounds guide you as we begin tonight's journey into the unknown. Section 1. The Silent Blueprint of Reality. Breathe in and now, breathe out. Let the gentle weight of your body find its perfect place of rest, a soft impression in the fabric of the night. Here, in this quiet space between wakefulness and dream, the grand questions of existence feel less like daunting problems and more like soft, unfolding mysteries. Tonight, we drift into one of the most profound of these mysteries, a question that lies beneath every scientific equation, every technological marvel, every glance you've ever cast toward the stars. It is the question of the laws themselves, the silent, invisible rules that govern everything. Think of gravity, the constant, faithful companion that holds you to your bed, that keeps the moon in its celestial dance and pulls the entire galaxy into a slow, magnificent spiral. Think of the laws of thermodynamics, the reason for the gentle warmth radiating from your own skin, the principle that dictates the slow cooling of a forgotten cup of tea, and the eventual, inevitable drift of the universe toward a state of quiet equilibrium. Think of electromagnetism, the force that carries the light from a distant star across unfathomable voids to meet your eye, the very same force that allows the neurons in your brain to flicker and spark, creating the thoughts you are thinking right now. These laws are the bedrock of our reality. They are consistent, predictable, and universal. They are the grammar of the cosmos, the syntax that allows matter and energy to form coherent sentences. But here is the gentle, curious question that we'll explore tonight. Where did this grammar come from? Did we, as a clever and inquisitive species, simply discover these laws, like an explorer stumbling upon a hidden continent that was always there, its mountains and rivers waiting patiently to be mapped? Were we like cosmic archaeologists, carefully brushing away the dust of ignorance to reveal a pre-existing, immutable blueprint for the universe? Or is it possible that the truth is something far more intimate and perhaps far more strange? Could it be that these laws are not discovered but invented? Are they the magnificent, intricate tools that we, the observers, have crafted to make sense of a reality that might, in its deepest essence, be a seamless, lawless, and chaotic whole? Are we like poets, creating a beautiful and functional language of mathematics and physics to describe an experience that is ultimately beyond words? Are we painting a picture of the universe, and in our focus on the brushstrokes, are we mistaking our painting for the landscape itself? This is the gentle divide we will wander through tonight. A path forking in two directions, both leading into landscapes of profound wonder. Let's first imagine the universe as a vast, ancient library. A library that has existed for billions of years before the first flicker of human consciousness. In this library, the shelves stretch into infinity, filled with volumes bound in starlight and dust. Each book contains a fundamental truth, a law of nature, written in a language we do not yet know. The law of gravity is there, a heavy, leather-bound tome. The principles of quantum mechanics are there, perhaps as a set of strange, shimmering pamphlets that change when you try to read them. In this vision, humanity's role is that of a humble, awestruck librarian. We arrive, late in the day, and begin the painstaking process of learning the library's alphabet. Newton was one such librarian. He saw an apple fall, and it was as if he found a Rosetta Stone. He began to translate a single, elegant sentence from one of the great books, the law of universal gravitation. He didn't write the law, he revealed it. He pulled back a curtain, and for the first time, we saw a piece of the universe's underlying architecture. The scientists who followed Faraday, Maxwell, Curie were all fellow translators, each deciphering a new chapter, a new verse from this grand, pre-written cosmic text. They were reading what was already there. This idea has a deep, resonant comfort. It suggests an objective, solid reality that exists independently of us. It means that the truth is out there, a firmament of certainty waiting to be uncovered. The universe, in this view, is not arbitrary. It has an inherent logic, a beautiful and consistent set of rules. Our journey is one of alignment with this truth. We are slowly, generation by generation, bringing our understanding into closer harmony with the way things truly are. The universe is the silent, master architect, and we are its apprentices, trying to read the blueprint. We look at the perfect, hexagonal symmetry of a snowflake and feel we are glimpsing a thought from the mind of nature itself. We see the golden ratio spiraling out in a nautilus shell or a distant galaxy, and it feels like we are tracing a signature left by the original creator. This perspective fills us with a sense of purpose and wonder. It makes science a sacred act of revelation. Every experiment, every telescope pointed at the night sky, becomes an act of listening, of trying to hear the faint, timeless music of the spheres. We are not just making things up. We are participating in a grand unveiling of truth. The laws of physics are not just our ideas. They are echoes of a deeper, more profound reality, a reality that would exist whether we were here to notice it or not. The moon would still orbit the Earth, and stars would still fuse hydrogen into helium, even if no mind had ever evolved to wonder why. The laws are woven into the very fabric of space-time, and our greatest achievement is simply to catch a glimpse of the pattern. But now, let's allow our minds to drift gently down that other path. Take a soft breath, and let the first idea settle. Now imagine something else. Imagine that the universe is not a library, but a single, unutterable, and seamless whole. It is not a collection of things governed by rules, but rather it just is. A vast, dynamic, and interconnected ocean of existence, without any inherent divisions or separate laws governing its flow. From this perspective, the human mind is not a librarian. It is a mapmaker. We arrive in this vast, featureless ocean of reality, and to navigate it, to survive in it, we must create a map. We draw lines of longitude and latitude. We name the currents. We chart the depths. These lines and names gravity, electromagnetism, the strong and weak nuclear force do not exist in the ocean itself. They exist on our map. They are the conceptual grid we lay over reality to make it comprehensible to our specific, limited, and beautifully unique way of thinking. Our brains evolved not to understand the ultimate nature of reality, but to help us find food, avoid predators, and build communities. We perceive the world through a very particular set of senses. We see a sliver of the electromagnetic spectrum we call visible light. We hear a narrow range of frequencies. Our minds are brilliant at recognizing patterns, at creating cause and effect narratives, because that is what kept us alive. So, when we look out at the cosmos, are we truly seeing its inherent rules, or are we projecting our own pattern-seeking, cause and effect-loving nature onto it? Think of a constellation like the Big Dipper. The stars that form that shape are not actually connected. They are vast distances from one another, moving in different directions, and they just happen to form a familiar shape from our particular vantage point on Earth. The Big Dipper is not a discovery. It is an invention. A pattern we imposed. Could the laws of physics be like that? A grand, celestial dot-to-dot game we are playing with the universe? We call a certain predictable behavior gravity and write elegant equations to describe it, but perhaps we are just describing a recurring pattern, not an underlying law. We have created a language. Mathematicat is exceptionally good at describing these patterns. But is the language itself a human invention, a product of our logical minds? This view doesn't make science any less magnificent. In fact, it makes it a towering monument to human creativity. It turns Newton and Einstein not into translators, but into something more akin to Shakespeare or Beethoven. They didn't just read the story. They gave it a voice, a structure, a narrative. They composed a symphony that so perfectly matches the rhythms of the cosmos that we can use it to predict the future, to build bridges, to fly to the moon. The laws of physics, in this light, are our collective masterpiece. They are the most successful story ever told, a story so powerful and predictive that it allows us to shape the world around us. This path is unsettling for some, as it removes the comfort of a solid, objective truth. It suggests that if a different kind of intelligent life evolved, with different senses and a different kind of mind, they might devise a completely different set of physical laws. Their science, their mathematics, might be unrecognizable to us, yet it could be just as effective for them in describing and manipulating their reality. The universe, then, might have no single blueprint. It might be a block of marble, and each intelligent species that arises is a sculptor, carving its own understanding, its own statue of reality, from the same raw material. So, here we are, drifting in the quiet of the night, suspended between two profound and beautiful ideas. Are we readers of a cosmic book, or are we the authors? Are we discovering the secrets of the universe, or are we creating the very tools that allow for secrets to exist? The truth may not be a simple choice between one or the other. It may lie in the shimmer, in the gentle space between them. For now, just allow the question to float in your mind, without the need for an answer. Let it be a soft, glowing lantern, illuminating the path ahead as we journey deeper into the night. Section 2. Whispers from a Perfect Realm. Let's wander down that first path together now. The path that tells us the laws of nature, our discoveries. Feel your mind settle into this idea, like sinking into a comfortable, well-worn armchair. This is the path of objective truth, of a universe that has a secret, steady heart, and our life's great quest is to learn its rhythm. To truly feel this idea, we must drift back in time, over 2,000 years, to the sun-drenched groves of ancient Greece. Here, the philosopher Plato imagined our reality in a way that still echoes in the quiet halls of science. He asked us to picture ourselves in a cave. Since birth, we have been chained, facing a stone wall. Behind us, a fire burns, and between us and the fire, objects are carried back and forth. All we ever see, all we have ever known, are the flickering shadows these objects cast upon the wall. We give the shadows names, we study their behavior, and we believe this dance of shadows is the entirety of reality. But what if, Plato wondered, one of us could break free? What if we could turn around and see the fire and the objects themselves? And what if we could then stumble out of the cave, into the sunlight, and see the world as it truly is, in all its luminous, three-dimensional glory? The shadows on the wall were not false, but they were a pale, flat imitation of a much richer, deeper reality. This is the very essence of the discovery viewpoint. It proposes that the physical world we observe with our sense is the messy, chaotic, and ever-changing world of falling leaves, boiling water, and crashing waves like the shadows on the cave wall. It is real, but it is an imperfect reflection of a deeper, hidden realm. A realm of perfect, eternal, and unchanging truths. This is the realm where the real laws of physics reside. They are not physical objects, but perfect ideas, crystalline concepts. They are the forms, the original blueprints from which our physical universe is constructed. From this perspective, a scientist is the one who has begun to turn away from the shadows. Through the power of reason, logic, and mathematics, they are catching a glimpse of the true objects casting them. The law of gravity isn't just a description of how an apple falls. It is a glimpse of the perfect, underlying form of gravitation itself, a truth that exists in this higher, silent realm. The language of this perfect realm, its native tongue, is mathematics. This is perhaps the most powerful and beautiful argument for the idea of discovery. Consider the number pi, the ratio of a circle's circumference to its diameter. We can write it down, 3.14159. And we can use supercomputers to calculate it to trillions of digits. But we are not inventing those digits. We are revealing them. The entire, infinite, non-repeating sequence of pi already exists in its entirety as a perfect concept. Our calculation is a journey along a pre-existing path, not the act of paving it. Whether a human mind had ever existed to think about circles or not, this ratio would still be an inherent property of the geometry of space. It was waiting in the silence for us to find it. Think, too, of the Pythagorean theorem. In any right-angled triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. This is not a human opinion. It is not a cultural convention. It is a fact, a timeless truth woven into the very fabric of logic. We discovered it. We gave it a name. But its truth was always there, patient and waiting. Now, if we accept that these mathematical truths are discovered, not invented, then what does that say about the laws of physics, which are expressed in the language of mathematics? When Einstein wrote down the sublime equation E equals mc squared, was he simply creating a clever model? Or was he, like a cosmic poet, translating a single, perfect verse from the book of reality? The equation suggests that energy and mass are two sides of the same coin, a fundamental, pre-existing relationship. The equation is our description, but the relationship itself is the truth. It was this relationship that powered the stars for billions of years before Einstein was born. He didn't invent the furnace. He simply read the maker's instructions. This is why this view feels so intuitive, so right to many. We see evidence of this hidden mathematical order everywhere we look in nature. It feels like the universe is leaving us clues, whispering its secrets. Look at a snowflake. Each one is unique, yet each one is built upon a foundation of perfect hexagonal symmetry. This six-fold pattern isn't an accident. It is the direct physical manifestation of the most efficient way for water molecules, with their specific shape and electrical charges, to bond together in cold air. The snowflake is a tiny, frozen piece of geometry. It is a physical shadow of a perfect mathematical form. Or think of the Fibonacci sequence, where each number is the sum of the two preceding ones. 1, 1, 2, 3, 5, 8, 13, and so on. This sequence mysteriously appears throughout the natural world. You can find it in the number of petals on many flowers, in the spiral arrangement of seeds in a sunflower head, in the branching of trees, and the uncurling of a fern. This numerical pattern seems to be one of nature's favorite building blocks. Are we just imposing this pattern because we like it? Or are we recognizing a genuine, underlying mathematical principle that governs growth and efficiency? The Platonic view would say we are recognizing a truth. We are seeing the fingerprint of the master architect. In this universe, the laws are steadfast and eternal. They are the silent, invisible scaffolding upon which all of reality is built. They are what make the universe comprehensible at all. If the laws were just our invention, just a story we tell ourselves, why would they be so extraordinarily powerful? Why would our mathematical inventions allow us to predict the existence of a planet like Neptune before we ever saw it through a telescope? Why would our story about general relativity so perfectly predict the bending of starlight around the sun, a phenomenon later confirmed by observation? This is what the physicist Eugene Wigner called the unreasonable effectiveness of mathematics in the natural sciences. It is almost a miracle that this abstract language we developed, seemingly from the depths of our own minds, corresponds so perfectly to the workings of the physical world. For the Platonist, there is no miracle. It is not unreasonable at all. It is what we should expect. We are not inventing a language and then finding, to our surprise, that the universe happens to speak it. We are, instead, slowly and painstakingly learning the universe's native tongue. Imagine the universe as a grand, silent symphony, a piece of music composed at the moment of the Big Bang. Its melody is the path of planets, its harmony is the interaction of particles, its rhythm is the flow of time itself. For eons, this symphony played to an empty hall. Then we arrived. We are the audience, and some among us these scientists have an exceptionally good ear. At first, they could only make out a few stray notes. Newton heard the deep, resonant theme of gravity. Maxwell deciphered the soaring, electric melody of light. Einstein heard the grand, sweeping chords of space-time, the very structure of the composition. They are not composing the music. They are transcribing it. They are trying to write down the sheet music for a symphony that has always been playing. Our theories are our best attempts at that transcription. Sometimes we get a note wrong, and a new generation of musicians comes along to correct it. But the music itself, the underlying, perfect, beautiful symphony of the laws of nature remains unchanged, playing on forever, inviting us to listen ever more closely. So, just for a moment, let your mind rest in this idea. Feel the solid ground of an objective reality beneath you. Feel the comfort in knowing that the universe is not a chaotic mess, but a place of deep, hidden order. There is a truth out there, a beautiful, elegant, and timeless set of rules that governs everything, from the dance of galaxies to the gentle rise and fall of your own breathing. Our role is one of wonder, of humility, and of perpetual, joyous discovery. We are listeners, standing on the shore of a cosmic ocean of truth, waiting to see what new treasures the tide will bring. Section 3. The universe through our eyes. Let that feeling of solid ground linger for a moment, the comforting thought of a universe with a perfect, hidden blueprint, a symphony waiting to be heard. It is a beautiful idea, one that has given purpose and meaning to our search for knowledge for centuries. It speaks of a reality that is firm, reliable, and ultimately knowable. But now, with a soft, gentle breath, let us lift our anchor from that solid ground. Let us drift away from the shore of certainty and turn our gaze inward. Let us wander down that second path we spoke of earlier, the one that whispers a different, and perhaps more startling, secret. What if the story of the universe is not really about the universe at all? What if the story is about the storyteller? What if the laws of physics are not eternal truths we find, but magnificent structures we build? This path begins not in the cosmos, but inside you, inside the quiet, intricate galaxy of your own mind. Think about the very tools you use to perceive the world. Your eyes, your ears, your sense of touch. They feel like clear windows onto reality, do they not? But they are not. They are filters, exquisite and highly specialized. Your eyes are tuned to a sliver of the electromagnetic spectrum so narrow that it is almost comical. You see the warm glow of a red berry, the deep blue of the sky, but you are utterly blind to the radio waves that carry voices across the globe, the microwaves that heat your food, the infrared radiation that pours from your own body, the X-rays that can see through your skin. All of this is light, all of this is real, and yet your reality does not contain it. It is filtered out. Imagine, just for a moment, the world of a dog, a reality built not on sight, but on a symphony of sense 1,000 times more complex and detailed than our own. A single footprint on the ground tells a story of who passed by, when they were there, and what they had for lunch. Or think of the bat, navigating in utter darkness by painting its world with sound, seeing the shape of a moth through the echoes of its own high-pitched calls. Would their science, their laws of nature, be the same as ours? If their primary way of understanding reality was through scent or sound, would they have ever conceived of a law based on the speed of light? Would they have built their physics around gravity, a force they cannot see or smell or hear, but only feel as a persistent background pressure? This is the first gentle crack in the idea of a single, objective truth. It suggests that our picture of reality is profoundly shaped by the kind of creature we are. Our minds did not evolve to grasp the ultimate nature of space-time. They evolved on the African savanna with a much more pressing set of priorities: to find the next meal, to understand the intentions of our tribe members, and to not get eaten by a lion. Our brains became the most sophisticated pattern recognition machines on the planet. We see faces in the clouds, connect the rustle in the grass with a hidden predator, and link the planting of a seed with the eventual harvest. This talent for finding patterns, for creating cause and effect stories, is our evolutionary superpower. Now, we turn this superpower towards the heavens. We look at the vast, complex, and chaotic dance of the cosmos, and what do? We find patterns. We draw lines between the stars and call them constellations. We see the planets move in predictable arcs, and we call it an orbit. We feel a constant pull, and we call it gravity. Is it possible that we are just doing what we have always done? Are we imposing our human, pattern-seeking way of thinking onto a universe that may not, in itself, be organized in such a neat, story-like way? The physicist Sir Arthur Eddington offered a beautiful and simple analogy. Imagine a marine biologist who sets out to study the creatures of the deep sea. He casts a large net into the water, a net with a mesh size of 2 inches. He trawls the ocean for days, and when he pulls up his net, he examines his catch. He finds all sorts of wonderful fish, but he notices they all have one thing in common. They are all larger than 2 inches. After many such expeditions, he formulates a fundamental law of marine biology. There are no fish in the sea smaller than 2 inches. Of course, the law is wrong. The sea is teeming with fish smaller than 2 inches. His law is not a discovery about the sea, it is a discovery about his net. He has simply projected the limitations of his own tool onto the reality he is studying. Could our science be like this? Could the laws of physics be a reflection of our net, our senses, our mathematics, our experimental methods? When we say that energy is always conserved, that it can neither be created nor destroyed, are we stating a fundamental law of the universe? Or are we describing a feature of our own closed, carefully controlled experiments, where we have defined energy in such a way that its conservation is a built-in, logical necessity? We are, in a sense, measuring the size of the mesh in our own net. This viewpoint reframes the unreasonable effectiveness of mathematics in a completely different light. It is no longer a miracle that our invented language of math so perfectly describes the universe. Of course it does. We built the language for that very purpose. It is like designing a key and then being astonished that it fits the lock you also designed. We see a pattern in nature. We invent a mathematical concept to describe it, and then we are amazed at how well the math fits the pattern. Mathematics, from this perspective, isn't the language of God. It is the language of the human mind, a language of pure, abstract logic and pattern. And because we are pattern-seeking animals, we find it to be an incredibly useful tool for organizing our perceptions of the world. This does not diminish the grandeur of science. It transforms it. The scientist is no longer a humble scribe, transcribing a pre-written text. The scientist is a master artist, a creator of profound and beautiful works. Newton, in this view, did not discover gravity. He invented the concept of gravity. He created a single, elegant, and powerful idea that, for the first time, united the falling of an apple with the orbit of the moon into one coherent story. It was an act of breathtaking creative genius. Einstein was not just a cosmic archaeologist who uncovered the secrets of space-time. He was a visionary who reimagined the very concepts of space, time, and gravity, weaving them into a new and more powerful tapestry of understanding general relativity. Our physical laws, then, become our most successful fictions. This doesn't mean they are false. A great novel can tell us deeper truths about the human condition than a list of facts. In the same way, our physical laws are true, in the sense that they are incredibly useful, predictive, and allow us to build technologies that work. They are a functional, beautiful, and coherent way of organizing our experience of reality.
But they're still our way.
They are the map, not the territory. And a different mapmaker, with a different mind and different senses, might draw a very different, yet equally functional, map of the same territory. So let your mind float with this idea. The universe is not a book to be read, but a silent, seamless reality. And we, with our unique human consciousness, are touching it, observing it, and in the process, we are co-creating the very structure we perceive. The laws of nature are not out there, waiting in the cold void. They are in here, born from the warm, creative spark of human cognition. When we look out at the grand, orderly cosmos, with its elegant laws and predictable cycles, perhaps we are not seeing the face of the universe. Perhaps, in the deepest, most profound sense, we are seeing our own reflection. Section 4 is Mathematics a Found Language? We have walked two diverging paths in the quiet forest of this question. One path led to a universe of discovered truth, an ancient text of reality, waiting to be read. The other led to a universe reflected in the mirror of our own minds, a story we compose to make sense of the silence. And at the very heart of this forest, where the two paths almost meet, stands a figure of profound and beautiful mystery. That figure is mathematics. In our journeys so far, we have seen mathematics cast in two different roles. On the one hand, it is the star witness for the Platonic view, the perfect, eternal language of the cosmos that we are simply deciphering. On the other hand, it is the primary tool of the human mind, the intricate net we use to cast over reality, a language we invented to describe the patterns we perceive. So, let us now, in the gentle quiet, turn our full attention to this enigma. Let us sit with mathematics itself and listen to the story it tells. For the key to our entire question, discovered or invented, may lie hidden within the nature of numbers, shapes, and patterns. Let us once again feel the pull of the Platonic realm. Let us speak to the mathematicians themselves. If you ask them what they're doing when they are deep in their work, very few will say they are inventing. The feeling they so often describe is one of exploration. They feel like cartographers, venturing into a vast and unseen continent of pure thought. The continent is already there, its mountain ranges of number theory, its deep oceans of geometry, its strange, tangled jungles of topology. Their work is to map it, to discover its features, to find the hidden paths that connect one region to another. Think of prime numbers, those numbers divisible only by 1 and themselves. 2, 3, 5, 7, 11, and so on. They are like the fundamental elements of the numerical world. We didn't invent them. They are a property of the very idea of number itself. For thousands of years, we have been exploring their territory. We proved that there are infinitely many of them. This was a discovery, a landmark on the map. We are still searching for a simple pattern in their distribution, the famous Riemann hypothesis. This search feels like a hunt for a hidden law of this mathematical nature, not an attempt to create one. Or consider a more modern wonder, the Mandelbrot set. It is an infinitely complex shape generated by a startlingly simple equation. When you begin to zoom into its fractal coastline, it reveals an endless, recursive world of breathtaking beauty and intricacy. You find tiny, distorted copies of the larger shape, swirling patterns, and structures of such detail that they defy description. The mathematicians who first saw these images on a computer screen did not feel like they had invented them. They felt like they had opened a window into another dimension. The simple equation was the key, but the infinitely complex dragon it unleashed was already there, sleeping within the logic of the numbers. They didn't build the dragon, they woke it up. This is the core of the Platonist argument for mathematics. Its truths feel objective, eternal, and independent of human minds. The truth that 2 plus 2 equals 4 does not feel like a human opinion. It feels more certain than any physical law we know. The laws of physics, after all, are just our current best theories, subject to revision. Newton's gravity was replaced by Einstein's. But 2 plus 2 will never equal 5. This suggests that mathematics is a deeper, more fundamental layer of reality than the physical world itself. It is the bedrock upon which physics is built. Now let that feeling settle. The feeling of mathematics as a discovered, eternal landscape. And with a soft breath, let's turn the idea over, like a smooth stone in your hand, to look at its other side. This is the side of the formalist, the constructivist. To them, mathematics is not a landscape to be explored. It is an elaborate and beautiful game, invented by humans. Like chess. The game of chess has a set of starting pieces and a few simple rules or axioms. You have a king, a queen, rooks, bishops, knights, pawns. Each moves in a defined way. From these simple, man-made rules, an almost infinite complexity emerges. There are brilliant opening gambits, complex mid-game strategies, and elegant endgame solutions. There are books filled with chess theorems. But no one would seriously argue that the truth, oh, Section 5. The shifting shape of gravity. Let the paradox of mathematics settle in your mind, a soft, glowing ember in the darkness. We don't need to solve it. We can just feel its warmth. Now, from this place of wonder, let's turn our attention back to the physical laws themselves. If we want to understand if these laws are discovered or invented, perhaps the best way is to watch one of them change over time. Like watching a sculptor at work, we can learn by seeing how the form takes shape, how it is refined, and sometimes, how it is completely reshaped into something new. There is no better subject for this than gravity. Gravity feels like the most fundamental, the most real, the most discovered law of all. It is the first force we learn about as children. It is constant, relentless, and universal. It seems less like a theory and more like a simple fact of existence. And yet, our understanding of this fact has undergone a transformation so profound that it perfectly illuminates our central question. For millennia, gravity was simply a tendency. It was the nature of earthy things to fall to the earth, and airy things to rise to the sky. It was a property of objects themselves, an innate desire to return to their natural place. There was no law of gravity, just an observation of how the world worked. The universe was neatly divided into two realms, the terrestrial and the celestial. Down here, things fell. Up there, in the heavens, the planets and stars moved in perfect, eternal circles, governed by entirely different, divine rules. Then, in the 17th century, a mind of singular genius looked at this divided universe and decided to unite it. Isaac Newton, sitting in a garden, perhaps watching an apple fall, had an insight that would forever change our picture of reality. He imagined that the force pulling the apple to the ground might be the very same force that holds the moon in its orbit around the Earth. This was a revolutionary leap of creative imagination. He wasn't just observing, he was proposing a new, universal story. To tell this story, he invented a new language, calculus. And using this language, he wrote down his law of universal gravitation. This law was a revelation. It stated that every object in the universe attracts every other object with a force proportional to the product of their masses and inversely proportional to the square of the distance between them. It was stunningly simple and unimaginably powerful. With this one elegant sentence, Newton erased the boundary between the heavens and the earth. The falling apple and the orbiting moon were now just two different verses of the same cosmic poem. His law could predict the tides, the paths of comets, the slight wobble in the Earth's axis. It worked so perfectly that for over 200 years, it was considered the absolute, final truth about gravity. It was a discovery. The chapter on gravity, in the Great Book of the Universe, had been read and transcribed. This Newtonian view of gravity feels very much like a discovered law. Gravity is a force, an invisible, instantaneous pull that acts across empty space. It is a fundamental property of the universe, and Newton simply found the mathematical equation that described it. He was the brilliant archaeologist who had unearthed the blueprint. For 2 centuries, we lived in Newton's universe, a universe of absolute space and absolute time, a grand, predictable clockwork machine, set in motion by a divine watchmaker and governed by his perfect, immutable laws. But then, at the turn of the 20th century, another mind came along, a clerk in a Swiss patent office, who began to think about light and time and motion. Albert Einstein was troubled by Newton's gravity. How could this force act instantaneously across the vast emptiness of space? How could the sun know, in an instant, that the Earth was there to be pulled? It seemed like spooky action at a distance, a piece of magic that didn't fit with his developing ideas about the finite speed of light. Einstein did not set out to correct Newton's law. He set out to reimagine it from the ground up. He performed thought experiments, imagining what it would be like to ride on a beam of light or to be in an elevator in free fall. And from these acts of pure imagination, he created a new story of gravity, a story so radical and so beautiful it still takes the breath away. In Einstein's story, which he called the general theory of relativity, gravity is not a force at all. It is a consequence of the shape of the universe itself. He proposed that space and time are not separate, absolute things, as Newton believed. They are woven together into a single, dynamic, four-dimensional fabric, space-time. And this fabric is not flat. It can be warped and curved by the presence of mass and energy. A massive object like the sun does not pull the Earth. Instead, it creates a deep well, a curve, in the fabric of space-time around it, like a heavy ball placed on a stretched rubber sheet. The Earth, in its orbit, is not being pulled. It is simply following the straightest possible path through this curved space-time. The moon does not orbit the Earth because of a mysterious force. It is rolling along a groove in space-time created by the Earth's mass. The falling apple is not being pulled. It is following the natural downward slope of the space-time right here in this room. This is a breathtaking shift in perspective. Newton described the effects of gravity with incredible accuracy. Einstein, we believe, explained what gravity is. But which view is the discovery? If you are a Platonist, you would say that Newton discovered a very good approximation of the truth, like seeing a clear shadow on the cave wall. But Einstein, by breaking free, turned around and saw the object casting the shadow. He got closer to the real form of gravity. His general relativity is a deeper, more accurate reading of the universe's book. The curvature of space-time was always there. Einstein was just the first to have the vision to see it. Our confirmation of his theory, the observation of starlight bending as it passes the sun, the precise timing of GPS satellites which must account for relativistic effects, is just proof that his reading of reality was more accurate than Newton's. But now let's look at it through the other lens. From the invented perspective, this story looks very different. Newton and Einstein are not archaeologists. They are master sculptors. Both given the same raw block of marble, they observed phenomena of falling objects and orbiting planets. Newton sculpted a magnificent statue called Universal Gravitation. It was a powerful, beautiful piece of art that captured the essence of the phenomena for his time. Then Einstein came along and, using the new tools of non-Euclidean geometry and his own creative genius, sculpted an entirely new statue from the same block of marble. He called it general relativity. It is a more subtle, more comprehensive, and, to our modern eyes, a more beautiful statue. It accounts for more of the fine details of the marble, details that Newton's statue missed. But is it the true statue? Or is it just a better, more useful invention? We already know that Einstein's statue is not perfect. His theory of gravity does not fit with our other great theory of reality, quantum mechanics. At the center of a black hole, or at the moment of the Big Bang, the elegant equations of general relativity break down. They give us nonsense answers, infinities. This tells us that Einstein's story, as beautiful as it is not the final chapter. A new sculptor will have to come along, perhaps with a new creative language like string theory or loop quantum gravity, and carve a new, even more profound statue from the same block of marble. The history of our understanding of gravity, then, looks less like a steady, linear march toward a final, discovered truth. It looks more like a series of creative revolutions, paradigm shifts where we tear down the old conceptual structure and build a new, more powerful one in its place. Each law is a human creation, a story we tell that makes sense of the data available at the time. Newton's story was a masterpiece. Einstein's story is a masterpiece. The next story is yet to be written. So, as you lie here, feeling the gentle, persistent presence of gravity holding you in place, what is it that you are feeling? Are you feeling the pull of an invisible force reaching out from the center of the Earth, as Newton imagined? Or are you resting in a gentle valley in the fabric of space-time, a valley carved by the mass of our planet, as Einstein envisioned? The beauty is you don't have to choose. You can hold both of these incredible stories in your mind at once. You can appreciate Newton's law as a brilliant invention that allows us to send probes to Mars with stunning accuracy. And you can stand in awe of Einstein's vision of a dynamic, curving cosmos, a universe more like a living organism than a static machine. By watching the shape of gravity shift and change through our human history, we see the beautiful, intricate dance between discovery and invention. We are reaching for something real, but the tools we use, the stories we tell, and the concepts we build are all profoundly, wonderfully our own. Section 6. Weaving the Quantum Veil. Breathe in the quiet comfort of Einstein's universe, a reality of graceful curves and predictable paths. There is a grandeur to it, a sense of a deep and elegant order. Even in its strangeness, it feels solid. It is a universe we can, with enough imagination, picture in our minds. But now, our journey must take us to a place where pictures fail, where imagination itself is stretched to its breaking point. We must leave the realm of the very large, the planets, the stars, the galaxies, and drift down, 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 past the scale of falling apples and grains of sand, past the size of a living cell, smaller than a molecule, until we arrive in the kingdom of the atom. We arrive in the subatomic world. And here, in this shimmering, ghostly realm, the very idea of a law, of physics begins to feel like a whisper, a dream, a veil woven to shield us from a reality too strange to comprehend. This is the world of quantum mechanics. And if our understanding of gravity was like a statue being recarved, our understanding of the quantum world is like trying to describe the nature of mist. It has no fixed form. Its rules are not the firm, declarative sentences of Newton and Einstein. They are suggestions, probabilities, a language of perhaps and maybe. Let's begin with the most fundamental citizen of this realm, the electron. In our classical world, everything is one thing or another. A thrown ball is a particle. The ripples on a pond are a wave.
They are distinct concepts.
But an electron, when we are not looking at it, refuses to make such a simple choice. It is, in a way that defies our everyday logic, both a spread-out, vibrating wave of potential and a tiny, point-like particle. It is a contradiction held in a single, delicate existence. Imagine you are holding a coin. It can be heads or it can be tails.
Now, spin it in the air.
While it is spinning, what is it? It is neither heads nor tails. It is in a state of pure potential, a blur that contains both possibilities. Only when it lands, suddenly when the motion stops and it is forced to make a choice, does it become one or the other. This is the closest we can come to imagining the life of an electron. When it is flying through space, unobserved, it is like that spinning coin. It exists as a wave of probability, a cloud of possibility, spread out in space. It is not in any single location. It is in all of its possible locations at once. The moment we try to measure it, the moment we try to look at it to pinpoint its location, the coin lands. The wave of possibility instantly collapses, and the electron reveals itself as a particle in a single, definite spot. It is as if the universe is shy. It exists in a state of ambiguous, beautiful potential, but the moment we shine a spotlight on it, it blushes and jumps into a single, concrete reality for us. This is the famous observer effect, and it strikes at the very heart of our question. If the laws of physics are simply discovered, describing a reality that exists independently of us, then how can the very act of our looking change what is real? The Platonist dream was of a universe whose blueprint we could read without smudging the ink. But in the quantum realm, it seems that every time we try to read the blueprint, our touch rewrites it. This forces us to ask, what kind of law is this? The great equations of quantum mechanics, like the Schrödinger equation, are the crowning achievement of this field. But what do they describe? They do not tell us where the electron is. They do not predict a definite outcome, like Newton's laws predicting the exact arc of a cannonball. Instead, the Schrödinger equation describes the shape and evolution of that wave of probability. It is a law that governs the mist of potential. It tells us that if we were to look for the electron, we would have, say, a 40% chance of finding it here and a 10% chance of finding it over there. This is a profound shift. The laws are no longer descriptions of reality. They are calculations of likelihood. They feel less like a discovered blueprint of the universe and more like an invented set of rules for a game of chance. It is as if we have reached a level of reality so fundamental that we can no longer describe what is, and so we have invented a powerful mathematical system to describe what we are likely to find. We have created a set of rules for the observer. The laws are not about the electron, they are about our interaction with the electron. They are the user manual for probing the mist. This makes quantum mechanics feel like the ultimate expression of Eddington's net analogy. Our experimental questions, our acts of measurement, are the mesh of our net. When we ask a particle question like, "Where are you?" reality gives us a particle answer. When we ask a wave question like, "What is your frequency?" it gives us a wave answer. The law we discover seems to be a reflection of the question we chose to ask. We are not discovering the nature of the sea, we are discovering the properties of our net. And the strangeness does not end there. It deepens into something that Einstein himself found profoundly disturbing, what he called spooky action at a distance. This is the phenomenon of quantum entanglement. It is possible to create two particles, say two electrons, that are linked in a deep, mysterious way. They can be sent flying off in opposite directions, separated by miles, or even by light years. The quantum state of each particle is undecided, like our spinning coins. But the moment you measure one of them, the moment one coin lands and shows heads, you instantly know, faster than the speed of light, that its distant twin has landed on tails. There is no signal sent between them, no message that travels through space. It is as if they are not two separate things at all, but two parts of a single, unified reality that exists outside of our familiar notions of space and time. This deep interconnectedness defies our story of a universe made of separate objects interacting via forces. It suggests a holistic, seamless reality that our laws, with their focus on individual parts, are struggling to describe. So, where does this leave our quest? The quantum world seems to be the strongest argument yet for the invented nature of our laws. Here, the laws feel less like rigid, eternal truths and more like brilliant, pragmatic tools we have crafted to navigate a reality that is fundamentally uncertain, probabilistic, and participatory. The universe at this scale doesn't seem to be a book written in the language of certainty. It's a dance, and the observer is always part of the dance. Our laws are the choreography we have invented to make sense of the steps. In this misty, quantum garden, the distinction between the gardener and the garden, the observer and the observed, begins to blur and dissolve. When we look at the universe at its most fundamental level, we see a reality that seems to wait for our questions, that conforms to our measurements, that only solidifies when we pay attention. Perhaps the laws are not a blueprint we find, but a veil we weave. A veil of mathematics and concepts that we lay over the face of this shy, mysterious, and potential-filled reality. We are not describing the face behind the veil. We are describing the beautiful, intricate patterns that we ourselves have woven into the veil itself. Let your mind float in this quantum fog. There is no need for solid ground here. Just the gentle, pulsating rhythm of probability, the soft whisper of a universe that is not a statement of fact, but an infinite, shimmering invitation. Section 7. The echo of a deeper truth. Let your mind drift in that quantum mist where solid ground dissolves into a sea of probability and the observer and the observed are locked in an inseparable dance. It is here, in this strange and uncertain world, that the argument for our laws being invented seems at its strongest. The rules feel less like descriptions of an objective reality and more like the elegant and complex user manual we have written for ourselves as a guide to interacting with a universe that is fundamentally shy, shimmering, and strange. We have, it seems, woven a beautiful veil of mathematics to make sense of it all. But now, having settled into that thought, a new and profound question arises. A question that echoes back from the path of discovery, a question that makes the veil itself seem magical. If the laws of physics and the mathematics that underpins them are our own invention, our net, our map, our story, then we must face the most astonishing fact of all. The story works. It works in ways that are so powerful, so predictive, and so utterly surprising that it feels less like an invention and more like a prophecy. This is the gentle, haunting question that the physicist Eugene Wigner contemplated. He called it the unreasonable effectiveness of mathematics in the natural sciences. It is a quiet, philosophical phrase, but within it lies a sense of awe that borders on the spiritual. It is the acknowledgement of a miracle that lies at the heart of science. The miracle is not that our mathematics can describe what we already see. The miracle is that our mathematics, a product of pure human reason, so often leads us to truths we could never have imagined, predicting parts of the universe we did not know existed. If our laws are our own invention, this should not happen. An invented story should not be able to predict its own sequels with flawless accuracy. A map we draw should not suddenly reveal a hidden treasure that we, the mapmakers, knew nothing about. Yet this happens again and again in the history of science. Our invented language seems to know more about the universe than we do. Let's drift back for a moment to the 19th century, to the mind of James Clerk Maxwell. He was working to unify the disparate phenomena of electricity and magnetism. He took the known experimental laws and, through a process of brilliant insight and mathematical creativity, wove them together into a single, beautifully symmetric set of 4 equations. This was a towering act of invention, of creating a new, coherent conceptual framework. But then something remarkable happened. Within the pristine, abstract logic of his own equations, Maxwell saw an unexpected implication. The equations predicted that a disturbance in an electromagnetic field should travel outwards as a wave, like a ripple on a pond. The equations even allowed him to calculate the speed of this hypothetical wave. When he performed the calculation, using the measured constants of electricity and magnetism, he arrived at a number, approximately 300,000 kilometers per second. This was, to his astonishment, the precisely known speed of light. It was a moment of pure revelation. The equations he had assembled, his intellectual invention, had whispered a deep secret of the cosmos back to him. Light, the ancient mystery, was an electromagnetic wave. His net, designed to catch the fish of electricity and magnetism, had, by its very structure, predicted the existence and nature of a completely different creature. This is the unreasonable effectiveness Wigner spoke of. It feels less like invention and more like channeling a deeper truth. The story becomes even more ghostly when we return to the quantum realm. In the 1920s, the physicist Paul Dirac was searching for an equation that would describe the electron in a way that was consistent with both quantum mechanics and Einstein's theory of special relativity. He was playing with the abstract symbols, trying to create an equation that was mathematically beautiful and logically consistent. He wasn't thinking about new particles. He was trying to solve a puzzle in the language of mathematics. Finally, he found it. A beautifully elegant equation that perfectly described the electron. But the equation, like a cryptic oracle, had a quirk. It had 2 solutions. One solution described the electron, with its negative charge, exactly as expected. The other solution, mathematically just as valid, seemed to describe a particle that was identical to the electron in every way, but with a positive charge. It was an anti-electron. At the time, this seemed like a mathematical absurdity. The physical world was made of protons, neutrons, and electrons. There was no room for this phantom particle. Many urged Dirac to simply ignore this strange second solution as a meaningless artifact of the math. But Dirac trusted the unreasonable effectiveness of his beautiful equation. He boldly predicted that for every particle, there exists an antiparticle. His invention, his abstract mathematical sentence, was making a concrete, testable prediction about the very substance of reality. A few years later, the positron, the anti-electron, was discovered in cosmic ray experiments, its properties exactly matching what Dirac's equation had foretold. From the depths of a purely human, logical creation, a new piece of the universe had been summoned into view. What are we to make of this? This is the central paradox that brings our 2 paths, the discovered and the invented, into a shimmering, breathtaking collision. The Platonist, the believer in a discovered truth, smiles gently at this puzzle. For them, there is no puzzle at all. Of course the math works unreasonably well. It's because mathematics is not our invention. It is the very language the universe is written in. When Maxwell and Dirac created their equations, they were not inventing. They were successfully translating a few perfect sentences from the cosmic book. The fact that these sentences, once translated, implied other truths is simply a testament to the coherence of the original text. They had discovered a new gear in the cosmic clockwork and were then able to predict how the other gears must turn. But for the other side, for those who see our laws as human inventions, Wigner's question is a profound and difficult one. If math is just a game we invented, like chess, how did it predict antimatter? It's as if the rules of chess, invented in a vacuum, somehow predicted the existence of black holes. This requires a deeper, more mystical explanation. It suggests that the game we are inventing is not arbitrary. It suggests that the structure of our human logic, the very way our minds build patterns and create abstract systems, must somehow, miraculously, mirror the deep, underlying structure of the universe itself. Perhaps the very distinction between discovered and invented is the illusion. Perhaps it is a false choice. Imagine a finely crafted violin. Is the beautiful music it produces discovered or invented? The song itself is an invention of the composer, a creation of human spirit. But the principles of harmony, the physics of the vibrating strings, the resonance of the wooden body, these are properties of the universe that are discovered and harnessed. The music is a co-creation, a dance between the artist's intent and the universe's inherent properties. Perhaps our physical laws are like this. They are our composition, our creative story. But we are composing it on an instrument, a universe itself that has its own inherent tones, its own natural harmonies. Our process of science is a process of attunement. We are slowly, painstakingly learning how to play this magnificent instrument. We try a combination of notes, a mathematical idea, and at first, it sounds discordant and clumsy. So we adjust our theory, refine our equations, until suddenly, we hit a chord that resonates. A chord that is not only beautiful and simple, but that also causes other parts of the instrument to vibrate in sympathy, revealing new melodies we didn't intend to play. This is the echo of a deeper truth. It is the sound of our invented language resonating with a reality that is beyond it. It suggests a connection between our consciousness and the cosmos that is more intimate than we can imagine. The fact that the universe seems to understand our mathematics, that it answers our abstract questions with concrete physical realities, is the most profound discovery of all. It doesn't solve our question of discovered versus invented. It transcends it. It points to a universe that is not a cold, separate object for us to study, but a silent, creative partner in our quest for understanding. Section 8. A universe that knows we're watching. Let the beautiful mystery of that resonating chord settle in your mind. The idea that our invented language of science is in perfect tune with a silent, cosmic instrument. This brings us to a place of profound intimacy with the universe, a sense that we are not just separate observers, but participants in a grand, creative dialogue. Now, let's follow this thread of intimacy to its most startling and philosophical conclusion. We've explored the idea that the laws of physics might be shaped by our tools and our minds. We've wrestled with the unreasonable effectiveness of our inventions. But what if the connection is deeper still? What if the universe itself, and the very laws that govern it, are in some way dependent on our being here to see them? What if the universe, in a sense, knew we were coming? This is the strange and contemplative territory of the anthropic principle. In its simplest form, the principle is almost a tautology, a statement that is obviously true. It states that the conditions we observe in the universe must be compatible with our own existence as observers.
Of course they must.
If they weren't, we wouldn't be here to observe them. If gravity were just a little bit stronger, the universe would have collapsed back on itself moments after the Big Bang. If it were just a little bit weaker, stars and galaxies would never have formed. If the strong nuclear force, the glue that holds atomic nuclei together, were slightly different, there would be no carbon, no oxygen, no heavy elements out of which to build planets or people. We find ourselves living in a Goldilocks universe. The fundamental constants of nature, the values that are plugged into our physical laws, seem to be exquisitely, miraculously fine-tuned to allow for the emergence of complexity, stars, planets, and ultimately, conscious life. The list of these cosmic coincidences is long and astonishing. It is as if we are walking through a vast desert and we stumble upon a magnificent palace, perfectly appointed with water, food, and breathable air. It is certainly a lucky break. But at some point, you have to wonder if the palace was built for you. This is where the anthropic principle forks into two fascinating and very different interpretations, mirroring our two paths of discovered versus invented. The first interpretation, known as the weak anthropic principle, is the more sober and scientific one. It aligns with the idea of discovered laws. It says there is nothing special or miraculous about the fine-tuning. It's simply a matter of selection bias. Imagine there are countless universes, a multiverse, each with its own randomly assigned set of physical laws and constants. In the vast majority of these universes, the laws are a mess. They are badly tuned. In those universes, stars never form, chemistry is impossible, and they remain sterile, empty voids. We, by definition, could not exist in one of those universes. We could only ever find ourselves in one of the rare universes where the cosmic lottery happened to hit the jackpot, producing a set of laws that are just right for life. From this perspective, the laws are not tuned for us. We simply exist in the universe that is tuned. There is no deeper meaning. We are just the lucky winners of a cosmic game of chance. The laws are still objective, discovered facts of our particular universe, but the reason they are so life-friendly is that we couldn't possibly be here to ask the question if they weren't. The fine-tuning isn't a mystery to be solved, it's a condition of our own existence. It's like a fish wondering why the whole world happens to be made of water. There is no why. If it wasn't, the fish wouldn't be there to wonder. This view maintains a universe that is indifferent to us. It is vast, ancient, and ruled by chance. Our existence is a fortunate, but ultimately insignificant, accident. The laws are discovered, but the universe we discover is just one of an infinite number of random possibilities. But now, let your mind drift towards the other interpretation, the more poetic and far more radical one. This is the strong anthropic principle. It dares to suggest that the connection is not one of mere selection bias. It suggests that the universe, in some sense, must have given rise to observers. There are many ways to imagine this. Perhaps the universe is a goal-oriented system, and the emergence of consciousness is its purpose. The laws are the way they are in order to bring forth beings who can look back at the universe and appreciate its beauty. In this view, we are not an accident. We're the means by which the universe becomes aware of itself. The laws are not just a blueprint for matter and energy, they are a recipe for consciousness. The universe, in this telling, is like a seed, and its entire 13.8 billion year evolution, the Big Bang, the formation of galaxies, the fusion of elements in stars has been the slow, deliberate process of that seed growing into a tree that can finally bear the fruit of self-awareness. Us. This is a profoundly teleological view, one that imbues the cosmos with purpose and meaning. It places our existence at the very center of the cosmic story. But there is an even stranger, more mind-bending version of the strong anthropic principle, one that connects directly back to the ghostly world of quantum mechanics. Remember the observer effect? The idea that reality at the quantum level only solidifies from a mist of probability when it is observed? The physicist John Archibald Wheeler, a student of Einstein and a poet of science, took this idea to its ultimate conclusion. He proposed what he called the participatory anthropic principle. He asked us to imagine the universe in its earliest moments, just after the Big Bang. It was a pure quantum system, a vast, expanding wave of potential, existing in a superposition of all possible histories, all possible sets of laws. It was like our spinning coin, but the coin was the entire cosmos. For billions of years, this cosmic wave of potential expanded and evolved, containing within it the possibility of a universe with strong gravity, weak gravity, no carbon, and so on. It remained in this state of pure, uncollapsed potential until, on a small, watery planet, a species evolved that could build a telescope, turn it to the sky, and observe. According to Wheeler's breathtaking idea, it is this act of observation, happening billions of years later, that reaches back in time and collapses the quantum wave function of the entire universe. It is our looking at the universe now that forces it to choose a single, concrete history out of all the infinite possibilities, a history that is, by necessity, consistent with our own existence. In this view, we are not just observers. We are participants in the creation of reality itself. We are not just reading the book of the universe. Our reading of it is what writes the words on the pages. The universe and the observer are locked in a self-creating loop. The universe gives rise to observers, and the observers, by their very act of observation, give rise to the universe. This idea dissolves the distinction between discovered and invented into a single, shimmering, paradoxical whole. Are the laws discovered? Yes, because we find them to be consistent and real. Are they invented? Yes, because our participation is what makes them real. We are co-creators of the very reality we are trying to understand. The palace in the desert exists because we were destined to find it, and our finding it is what built it in the first place. So, as you rest here, feel the presence of the universe around you. The silent air in the room, the distant light of stars filtering through your window. Is this a reality that is utterly indifferent to you, one of countless random possibilities? Or is it a reality that has been waiting for you? A reality that is only made whole and complete by your conscious awareness of it? You don't have to believe the most extreme version of this story, but allow yourself to feel its poetry. The idea that your simple, quiet act of being aware, right here, right now, is not a passive event. It is an active participation in the grand, unfolding story of the cosmos. Your consciousness is not just a flicker of light on the surface of the universe. It is a vital part of its fabric, the thread that helps weave the pattern of reality. You are not just a spectator watching the show. You are the audience whose applause makes the performance real. Section 9. The Sculptor and the Stone. Let the idea of a participatory universe settle around you, a soft and wondrous cloak. The notion that your own awareness might be a necessary ingredient in the recipe of reality is perhaps the most profound turn our journey has taken. It has led us to a place where the paths of discovered and invented seem to merge and disappear. So, where do we stand now, in this quiet, thoughtful space, suspended between a universe that writes its own story and a universe whose story we write? Perhaps the time has come to lay down the burden of choosing one path over the other. The human mind loves clear distinctions, simple binaries. It is this or it is that. But the deepest truths of existence rarely fit into such neat boxes. They are often found in the fertile, creative tension between two seemingly opposite ideas. Perhaps the answer to our question is not a choice, but a synthesis. A beautiful and dynamic partnership. Let us embrace a new metaphor for this final leg of our journey. Let us set aside the image of the library and the mapmaker, and instead, picture a sculptor and a block of stone. This, perhaps, is the truest relationship between humanity and the laws of nature. The stone is the universe itself. It is the raw, objective reality that exists independent of us. It is the isness of things. It has an inherent nature, a definite character. It is not infinitely malleable. A block of granite cannot be sculpted into a cloud. It has its own properties, its hardness, its texture, its grain, the hidden fault lines that run through it. These properties are the true, discovered part of the equation. These are the fundamental constants of nature: the speed of light, the charge of an electron, the strength of gravity. These are the non-negotiable facts of our cosmos. They are the grammar of the stone itself. We did not choose them. We find them. And we are the sculptor. We come to this raw material with our consciousness, our curiosity, our creativity. We are the active principle, the force of inquiry and imagination. Our hands are our senses. Our eyes and ears are the first tools we use to understand the stone's shape and texture. But our tools become more and more sophisticated. Our particle accelerators, are powerful hammers. Our radio telescopes are sensitive chisels. And our most important tool, the one that holds our vision and guides our hand, is our mind. And the language of our mind, the cutting edge of our chisel, is mathematics. Now, think of the process of science in this light. It is not a passive reading of a pre-written book, nor is it a flight of pure fantasy, inventing things from nothing. It is a dialogue, a dance between the sculptor and the stone. The sculptor does not simply impose their will upon the material. A good sculptor begins by studying the stone. They run their hands over it. They tap it and listen to the sound it makes. They respect its nature. They look for the form that the stone itself seems to want to express. In the same way, a scientist begins with observation and experiment. We tap the universe with an experiment and listen to the results. We are constantly probing the nature of reality, asking it questions, respecting the answers it gives back, even when they are strange and unexpected. The stone's response to the data, the measurement is subjective. It guides our hand. But the stone alone does not create the statue. The final form, the work of art, comes from the vision of the sculptor. Out of the infinite number of forms the stone could potentially take, the sculptor chooses one. They bring their own sense of beauty, of symmetry, of elegance to the task. This is the invented part of our physical laws. Newton looked at the raw data of motion, the stone's properties, and with the chisel of his new mathematics, he sculpted the magnificent, clockwork statue of universal gravitation. It was his vision, his creative act. Then Einstein came along. He was not satisfied with Newton's statue. He felt it didn't fully respect the stone's deepest nature, particularly the properties revealed by the nature of light. So, with new tools of thought and a different artistic vision, he began to sculpt again. He did not change the stone. The universe was still the universe. But he carved it into a new, more profound form, the flowing, curving, dynamic statue of general relativity. This statue was a different interpretation of the same raw material, one that revealed deeper truths about its grain and structure. Our physical laws are these statues. They are our co-creations. They are a magnificent fusion of objective reality and subjective human genius. The law is not just the stone, and it is not just the sculptor's idea. The law is the finished statue itself, a testament to the partnership between the two. This metaphor helps us understand all the strange turns in our journey. The unreasonable effectiveness of mathematics. That is the sculptor's joy at discovering that their chisel is perfectly suited to this particular kind of stone. The mathematical ideas we create in the abstract world of our minds turn out to be the perfect tools for carving and understanding the physical world. The tool and the material seem to have been made for each other. The observer effect in quantum mechanics? This is the most intimate part of the dialogue. It is a part of the stone so strange and responsive that the very touch of the chisel helps to define the material itself. When we decide to sculpt a particle, the stone obliges and presents a particle-like face. When we choose to sculpt a wave, it presents a wave-like face. Here, the distinction between the sculptor and the stone becomes almost meaningless. The act of creation and the act of discovery are one and the same. And the anthropic principle? This is the realization that the stone itself is, miraculously, a material that is even capable of producing a sculptor. The raw material of the universe has the inherent properties required to eventually give rise to conscious beings who can then pick up their tools and begin the work of sculpting, of understanding, of creating the laws. So, we can finally let the two opposing ideas rest. We do not need to choose. The laws of physics are not simply discovered, nor are they simply invented. They are the emergent beauty that arises from the dance between a universe with a deep, inherent structure and a mind that is driven to find and create patterns. They are the song that is born from the meeting of the instrument and the musician. They are the statue, born from the meeting of the stone and the sculptor. There is a profound beauty in this synthesis. It returns to us a sense of intimacy and partnership with the cosmos, without losing the rigor and respect for objective truth. We are not just insignificant specks in a cold, indifferent universe. Nor are we lonely gods, making up reality as we go along. We are something in between. We are the universe's sculptors. We are the consciousness through which the silent, waiting stone can finally be shaped into a form of breathtaking beauty and meaning. Section 10. The beauty of the unanswered question. And so we rest here, in this quiet workshop of the mind, with the image of the sculptor and the stone. It feels like a place of peace, a synthesis that honors both the universe's objective reality and our own creative spirit. It is a beautiful story, perhaps the most complete and satisfying story we can tell ourselves about our relationship with the cosmos. It allows us to be both humble students and magnificent artists. But as you drift now, on the very edge of sleep, let us take one final, gentle step. Let us look at the beautiful statue we have carved, this idea of a co-created reality, and let us even be willing to let that go. For what if the deepest truth, the most profound gift of this entire cosmic journey, is not the answer in any form? What if the real treasure is the question itself? Think of it. For all of our journeying tonight, through Plato's cave, past Newton's clockwork, and into the shimmering quantum mist, we have been held by this single, gentle question, discovered or invented. It has been our constant companion, our guiding star. We seek an answer because our minds are built to seek resolution. We crave the comfort of a final destination. But imagine, just for a moment, that we found one. Imagine that tomorrow, a final, irrefutable proof was presented. A message from the heart of a black hole, or a perfect equation that unifies all forces, which proves beyond any doubt that the laws of physics are, say, a pre-written, discovered text. The great book of the universe is real, and we are its readers. For a moment, there would be exhilaration, a sense of triumph. But then, what would follow? The universe might suddenly feel a little smaller, a little less magical. Our role would be fixed. The great mystery would be solved, the adventure over. The dialogue would end, replaced by a monologue from the cosmos. Now imagine the opposite. Imagine it was proven with absolute certainty that all the laws are our invention. A story we project onto a chaotic, lawless void. At first, there might be a sense of pride in our own creative power. But a deep loneliness might follow. A feeling that we are alone in our own heads, shouting our elegant poems into an abyss that cannot hear or understand us. The connection, the sense of partnership with the cosmos, would be severed. Perhaps the true beauty, the true engine of our humanity, lies in the space between these two certainties. Perhaps the question is not a problem to be solved, but a sacred space to be inhabited. It is the tension of the unanswered question that keeps us alive, that keeps us curious, that keeps us humble. It is a horizon that we walk towards. The purpose of a horizon is not to be reached, but to give our journey a direction, to pull us forward into the vast and beautiful unknown. This question, discovered or invented, is the very heart of the scientific spirit. It is the engine of wonder. To believe completely in discovery is to risk becoming a dogmatist, a mere scribe who has forgotten to question the text. To believe completely in invention is to risk becoming a solipsist, a lonely artist who has forgotten that there is a real and magnificent world beyond their own canvas. The true scientist, the true explorer of reality, must live in the shimmering ambiguity between the two. They must be both a faithful listener and a daring creator. The value of the question is that it transforms your relationship with the world. The next time you feel the sun on your skin, you can feel it not just as warmth, but as a portal to this mystery. Are you feeling the effects of a fundamental law of thermodynamics that was written into the universe at the Big Bang? Or are you participating in a beautiful, human-created story about energy, heat, and entropy? The warmth is the same, but the question infuses it with a layer of wonder. The gentle pull that keeps you resting on your bed is no longer just gravity. It is a quiet invitation to contemplate Newton's force and Einstein's curves, to ask whether you are being pulled by an ancient rule or following a path you helped to create simply by being a conscious observer. The world is no longer just a collection of facts. It becomes a collection of beautiful, resonant questions. So, as we bring our journey to a close, let us not seek a final answer. Let us instead give thanks for the question itself. It is a gift. It ensures that the universe will never become a boring, fully explained machine. It ensures that there will always be room for mystery, for awe, for the next generation to come along and sculpt an even more beautiful statue from the same eternal stone. It keeps the dialogue between humanity and the cosmos alive, and it is in that living, breathing dialogue that all meaning and beauty are found. Let the question dissolve now, not into an answer, but into a feeling of profound and peaceful wonder. Let it be the gentle, rocking motion that carries you out onto the calm, deep ocean of sleep. The universe is vast and mysterious, and our place within it is both a great privilege and a beautiful puzzle. And for tonight, that is all it needs to be. And so, our exploration for tonight comes to a soft and gentle end. We have wandered through the grandest galleries of human thought, not to find a final truth, but to bask in the beauty of the questions themselves. The universe does not demand that you solve its mysteries before you can rest. It simply holds you in its silent, patient embrace, just as it has for billions of years before you, and just as it will for billions of years to come. The soft sounds will continue for a little while, a gentle current to carry you away from the shores of wakefulness. There is nothing left to figure out, nothing left to do but to let go. Let your breath be your anchor in this peaceful present moment. Feel the weight of your body, a gentle reminder of your own place in this vast, wondrous reality. Let the questions dissolve into dreams, and let the mystery cradle you as you sleep. May your rest be deep and your dreams be peaceful. Good night.